minus b is equal to AC. Air conditioning. I don't know what was funny about that. Nothing. I'm terribly sorry for that. I thought in my head that AC would be funny in this situation, but it wasn't. A huge thanks to Brian for sponsoring this video. Get money! Video. So just a little piece of information, we are all out of incredibly rigorous headphone stands over at stemage.eu. I simply don't have any mahogany wood left to produce new ones. I will keep you informed once there are new ones available, maybe also a new wood type at that. Up until this point, all we have left are other handcrafted products like the Tensegrities, which come in a lot of wood variants, so check them out. Or you can find this amazing looking merchandise over on stemage.eu to support the channel this way. Check it out. This was just a little PSA at the start. So a new episode of Mathematics Gone Wrong Done Right has been a while, and today I would like to talk about something very, very controversial, and I would like to use this opportunity to rage about the so-called thing mixed fractions, which has been created by the devil himself. It's like one of the most stupid pieces of mathematical notation that is out there, next to the using double dots to indicate division. Ugh. If I just think about it, it's freaking terrible, to be honest. And yeah, this is something that gets mixed up in schools so often. There's this one faction, not fraction, or yeah, you could say there's a part of the teachers, a fraction of the teachers, who loves to use mixed fractions because I don't know why you would use them. And there are people like me who want to imply that there is basically a multiplication between some kind of integer and b divided by c. Okay, this is something that mathematicians just agreed to basically a few hundred years ago, that if you don't write anything in between those two things, it means multiplication. But you have to teach it in schools that there are things called mixed fraction, where this right here actually means that there's a plus in between. You have a whole things and then a part of these things, okay? A plus b divided by c. And actually what we're going to find out today is if there are any solutions to this equation, namely the two factions of teachers or mathematicians put together in one equation. When is this true? A times b divided by c being equal to a whole things and b divided by c things. Okay, left. And now we are going to dive right in. So on left hand side we can't really do anything. All we can do is basically bring this a to the top, to the numerator. Meaning what we can do is we can say this is a times b divided by c. On the right hand side though, what can we do here? I mean, as mentioned a second ago, mixed fractions mean this is like the dumb little brother of just decimal expansions, and decimals are also pretty fucking stupid. No one needs decimals. I hate decimals. This is basically just the integer part plus the fractional part. So overall what this means is that this is a plus b divided by c. Now what we can do here is basically expand our a by c divided by c, meaning overall that this is a times c divided by c plus b divided by c. Or in other words, since we have the same denominator going on, what we can do is we can say that this is equivalent to saying a times b divided by c is equal to ac plus b divided by c. And now, under the condition that c is not equal to 0, and we can say that it's not equal to 0, otherwise this whole thing wouldn't make any sense at all, we can multiply both sides by c, or we can divide both sides by 1 divided by c, I don't care. You can do whatever you wish, but that would be a pretty stupid approach. We are going to get that a times b is equal to ac plus b. And yeah, this is basically where the magic is going to happen. Now we can solve for one variable here in terms of the other variables, and then just plug in a number and get infinitely many solutions for this given equation that we got right here. So for which one should we solve? I mean, we can solve, for example, for a, or we can solve for b. Let us solve for a for a second. So if we want to solve for a, we are going to subtract ac on both sides, giving us a times b minus ac is equal to b. And now what we can do is we can factor out the a, giving us overall that a times b minus c is equal to b. And now we can divide both sides by b minus c under the condition that it's not equal to 0, giving us overall a being equal to b divided by b minus c. Or we can go the other way around and solve, for example, for b in our case. Solving for b is going to give us, okay, this right here is one thing that we can make use of to find out what the value of a is going to be, for example, or for given b and c is to get ourselves some kind of a. Or what we can do on the other hand is we can solve for b here. In order for us to solve for b, or on this equation, we are going to subtract b on both sides, giving us a times b minus b is equal to ac. Air conditioning. I don't know what was funny about it. Nothing. I'm terribly sorry for that. I thought in my head that AC would be funny in this situation, but it wasn't. I'm so sorry. This was like a typical Matt Colbo moment. If you're watching, my boy, love your videos. Now we can factor out the b right here, giving us b times a minus 1 is equal to AC, and now we can divide both sides by a minus 1 under the condition that it's not equal to 0, giving us overall a second set of equations, namely b being equal to AC divided by a minus 1. And yeah, this is basically it. Now we got ourselves solutions, infinitely many at that, to this equation that we got up here. Now what would be a kind of boring one? For example, if we were to plug in a being equal to 2, for example. Okay, so if we got a being equal to 2, what is going to happen to our b? Our b is going to turn into 2 times c divided by 2 minus 1 is 1, so we are going to get 2 times c. Now if we were to plug in a value for c, for example, let's say c being equal to 1 isn't very nice, to be honest, because then we would get that a is equal to c, and this overall would just mean that a lot of stuff is going to cancel out on this side already. So let's say c is equal to 3, for example. Then we are going to get that b overall is going to be equal to 6. Meaning overall, in the process, what we are going to get is that, okay, a is 2, so 2 times 6 divided by 3 in our case is equal to 2 whole things, and since this is a mixed fraction, 6 divided by 3. And yeah, this should be probably a true statement. So if it were, this right here is a pretty boring example, just because of the fact that 6 and 3 are going to cancel out, meaning overall this right here is going to give us 2. So meaning on this side we are going to get 4, but this right here is a mixed fraction, giving us 2 plus 6 divided by 3, which is 2 plus 2, which is 4. And this right here is a special case for real numbers in general, namely that n times n, so n squared is equal to 2 times n. There's only one solution, namely for n being equal to 2. Other than that, let us go through another example, last one. Let us say that let us go for a kind of shitty example. I don't care. So let's say a is equal to 5, giving us overall that b is equal to, so we are going to get 5 times c divided by 5 minus 1 is 4. So 5c divided by 4. And since we would love to have actually whole numbers here or just integers in general, what we can also say is let c be equal to 8, for example. Then we are going to get that b is equal to, so 8 divided by 4 is 2, this gives us 10 overall. Meaning overall, another statement which should hold true overall is that 5 times 10 divided by 8 is equal to 5 whole things and 10 over 8. Yeah, giving us 6 whole things on this side and 2 over 8. And yeah, this is basically it. And I leave it as an exercise to the viewer to determine if this relationship now also holds for negative integers. Try it out and tell me in the comments what you think. And if you did enjoy the things that we did today, elementary number theory, just playing around with fractions in general, the difference between mixed fractions and multiplication of fractions, then definitely make sure to check out today's sponsor, Brilliant, who are kind enough to sponsor yet another video here on this channel. Now Brilliant, even though it's an English website and I'm teaching at a German school, has been a great resource for myself and also my students to learn about new things they have not learned about before, especially when it comes to geometry. Brilliant is your source for some of the best online learning content that you can find out there on the internet. It's not comparable with any other resource that I have found up until this point, and I don't want to miss Brilliant anymore. I was talking about geometry and showing all of this to my students before, and it's really a great resource. Especially in the geometry section over on Brilliant, you can experience triangles and other geometric figurines and their relationship with the angles and the sides firsthand by using their interactive learning concept. Interactive learning in the sense that you are not going to just get exercises that you are going to work through with detailed explanations being created by experts to assist you if you get something wrong. No, you can also make use of their nifty animations and graphics that you can even pull around. For example, with the triangles, you can find out what all the inner angles are going to be, or rather that they are going to stay constant, even though if you rearrange the edges of the triangles and play around with the corners and the likes. It's a lot of fun and you should definitely try it out. And if this feels like it's something for you, definitely make sure to check it out using the link at the top of the description, brilliant.org/emblemmaths. With it you are going to get free access to a big portion of Brilliant already, but most importantly, the first 200 people to actually make use of the link at 20% of an annual premium subscription, which is a freaking great deal considering how much content they have available on their website. It's not only mathematics, it's also physics, chemistry, computer sciences. Everything you can think of in the branch of STEM, you're going to find over there with a bunch of exercises attached to it. So definitely make sure to support the channel this way and to try it out. Thank you guys for watching. If you enjoyed this video, definitely also make sure to check out STEMage.io or support the channel on Patreon. And until the next video, I wish you guys a flammable day. Please stay safe. Ciao.